Hello everyone. So a few days ago I released a video that had quite a bit of success on Twitter and Reddit. And a few of you asked me to make a tutorial to show you how I did it. So yeah, that's what I'm trying to do right now. Before we start, I just want to point out that I'm not a VFX expert at all. As a matter of fact, I've started using Unity less than a year ago, and VFX Graph a few months ago. So there's probably a few things that I could have done better, and if some of you know any of these things, just feel free to add them in the comments. One thing I'd like to say before starting is that this tutorial is going to assume that you have some knowledge of how VFX Graph works and how math works, because I won't have time to go too in depth into what each node is doing to the graph. So here we are. That's a fairly standard HDRP empty scene. I just added a floor, which is basically a plane, and a shelf. It's very basic. It's just a few cubes. Now that's the book model that I made in Blender. It's very low poly, as you can see. It has an albedo texture and a normal map. So as you can see, it's as low poly as you can in order to, because we're gonna have thousands of them, so it makes sense to just keep them simple. Alright, so let's just create a new VFX in our project. I'll call it Magical Library, and then just drag it into the project. Let's bring it here and let's open it. So one of the first things we're going to do is to remove the default modules. We're going to set the capacity of the VFX graph to 15,000, which is what I used in the video, which is more than enough to get a very big shelf. And we're going to change the spawning to a single burst, which is going to happen when we load the scene. So I'll just set it to 30 for now, and then we're going to change the outputs from particle quad to a lit mesh, which is something you have to use HDRP in order to get the lit mesh, right? Won't work in URP. Change it to opaque and then choose our book mesh. Let's change the texture to our texture, and then it won't spawn unless I set the position first using a set position module. And here we go, we have a book, technically 30 books at the same place. Now we have a few settings to change, so you have to select the output particle lit mesh and then go into your inspector. There we're going to pick use normal map and cast shadows. Let's pick the normal map. Here you go. Just lower its strength a bit because I made it a bit too strong in Blender. Okay, now we have a book. Let's try to make this look a bit more like a full shelf. So first we'll create a particle index node, which is basically every particle that is spawned by the graph has a unique index, which is 0, 1, 2, 3, etc. And we're going to use this to actually spread the books, as you'll see very simply. So we create a new vector 3, and then we're going to plug the particle ID directly into the Z component of our vector 3. And then plug this vector 3 into our set position. And here you go. So basically each of the particle is 1 meter apart because it uses the index. Now what we're going to do is multiply this index by some arbitrary float value, and that will allow us to have whatever interval we want to have between each book. Okay, so we have to restart the VFX graph between each change because it's actually done into the initialize function. So that seems to be a pretty decent interval between each book. Well, we're going to try to add some particles. Let's restart the graph. And here you go. Now you have a long line of books. Now we're going to add different levels of books. So I'm going to call these floors because I'm not sure exactly what the right name would be in English. As you'll see, most of my variables have poorly chosen names, but hopefully it will be good enough for you to follow the tutorial. So here I just set it to 4 because we're going to have 4 floors by default. Plug in into a modulo node, which will give us basically 4 groups of particles. And then we're going to set to plug this modulo node into our y value. And here you go. We have different levels of books. However, you'll notice that the books are now much more far apart, so we have to divide our initial float by this floor amount value. And then we should get so that kind of looks like a shelf. Now we want to be able to control the space between each of the levels. So I just multiply this modulo node by, once again, an arbitrary float that I'll be able to change afterwards by making it an exposed property. So yeah, I warned you, my variable naming is very poor. Now I'm just going to create an int property that will allow us to control how many books are spawned by our VFX graph very easily from the inspector. Let's make it exposed. And now if you just change the book amount, or if you change the floor amount, here you go. So that's your most basic sort of procedural library. Now we're going to add a bit of randomness to make this more natural looking, right? To add randomness, the random number node is extremely useful. So we're just going to create one, which we're going to set between 2 pretty small floats, like -0.1 and 0.1, and we're just going to set it to the x value, right? So now each book is going to be offsetted by some amount on the x axis. So that was a bit too strong, so I'm just going to make it a bit smaller. There's a lot of trial and error when you do this sort of thing, so 0.02 should be fine. And then feel free to, just tweak the settings to fit your needs. We're going to do the same with the size. So very easily with the set size random. So we're going to put it between 0.01 and 0.11. And then we're going to add a multiply size so that we can easily control the overall size. So now, as you can see, it looks much more natural. One thing that I like to point out is that you need the pivot of your book mesh to actually be at the bottom of the mesh, so that the size is actually affected from that point. The next thing that we're going to randomize is the color of the books. It's going to be a very simple randomization based on white and some slightly darker gray, because it would be actually a bit more complicated to get nice color blending with more with different colors like red or green or blue. So yeah, here we're just going to be lerping these two colors, so one completely white and one that's going to be sort of medium gray. And we're going to use our trusted friend, the random number, between 0 and 1 and just set it. And here you go. As you can see, some of them are a bit darker, some of them are a bit brighter. One last thing we can do is add some random rotation to the book. So this one is going to be fairly subtle. So it's called angle, it's not called rotation for some reason. And I'm just going to randomize the X component. So here, just trying 10 degrees. It's pretty good. I'm just going to do a bit in both directions. No, that's a bit too strong. Let's do -5 and 5. As you can see, there's always the chance that two books will slightly overlap. That's something I have actually fixed in my full graph. But here, for the sake of this tutorial, I wanted to keep it fairly simple, and it's mostly completely invisible. So now we're going to try and integrate this sort of shelf generator to our shelf mesh. Try and find the right size first. Okay, so here one thing I'm going to do is to actually take all of the nodes that I've set up in the initialize phase and drop them into the output, because that actually allows me to set up everything in real time. The reason I've set it up in the initialize particle is that it makes just a lot more sense to me to have them initialized once at the start of the scene and then just to stay there. But it won't allow me to actually edit them in real time, so just to set up the library, I've put them all in the output section. Now what I'm doing is actually adding a float to control the interval between the books, because as you've seen, when we change the size of the books, the space is not right anymore. So yeah, it just seems easier to have this value to be exposed so that I can easily control it from the inspector. So now this is starting to look pretty nice. Bit more space. Now let's just have it tap to the mesh here. Let's just go all the way to the top to see, yeah. Bit more. Alright. Then we need to add 2 floors. Okay, so what you've seen here we're going to fix very quickly. Okay, now we're going to add a few books. As you can see, you have to restart the graph each time you change the amount of particles. So now we have to fix the fact that the books disappear sometimes. That's when the bounding box is not inside of the camera anymore. So to fix it, we'll create an AA box node and connect it to our bounds of the initialize module, and then we'll just make it a property and edit it very quickly in the editor so that it goes around all of our books. Now we can take all of these nodes back to the initialize part. You can leave them actually, I think, in the output particle. It just makes more sense for me and it's easier to know where I'm at. Now let's get to the second part, which is the magical floating books. So to do that, I'm going to lerp our position using another set position in the output to lerp between first the starting position, which is just the attribute position, and then between something else, which I'll have to create right now. So to start, I'm going to just add to the starting position a simple vector 3. On which I'm going to offset the Z component. And here you go now. So that was the wrong way, so let's just go the other way. And here you go. but we don't want all the books to go exactly at the same place, right? So we're going to randomize that by using, you've guessed it, a random number. So we're going to multiply this vector that we're adding by a random number. One thing we're going to want to do is to uncheck the constant boolean, because if we don't, every time we ask for a random number, we're going to get the same one. So the one that shows what color the books are, the one that shows what rotation the books are, and so we're going to have only the dark books go out further or something like that, and we don't want that. I'm using an animation curve in order to have a bit more control over the amount of books that is going, outwards, or because I want them to be spread in a very specific way from the shelf to, the air. Okay. Now we're going to want to add some movement to that, because that's very static. To do that, I'm just going to add another vector 3, and I'm going to use a sine node to which I'm going to feed the time. Let's just add a multiply node so I can change the speed later on, and just straight ahead. Ta-da! Magic books. So that's fine, but we probably want to have a bit more control over the speed. We also don't want them to move exactly in the same direction all the time. So we're going to use the same random number that we're going to add to the time, so that each book will be offsetted in the sine function. So now every single book has a different speed and a different offset. Now it would be nice to be able to just use the same sign to randomize every direction, but as you can see, it just makes the books go diagonally. So what I'm going to do is just duplicate these 3 nodes and then add another random number. Still no constant checked, and then if we add it to the z, yeah, as you can see, it's a bit more random. Although I'm still going to have to multiply. And I'm just going to keep the same one for the y component, because, yeah, it just looks random enough, in my opinion. Now this is still pretty rough, so let's try and make it look a bit better. So here I'm adding a multiply node on both in order to have a global speed attribute. All right. So now I'm going to add some, random angles. So for the sake of this tutorial, I'm actually going to keep the angles still. So I'm just going to give all the books a random angle when they are out of the shelves. So just like for the position, I'm just swapping between the angle attribute, which is set as the start of the graph, and a random angle. You probably want to actually animate the angles, and now with what I've shown you for the movement, You could probably very easily do it if you didn't know how beforehand, but here, to keep it short, I'll just add this random angle and call it a day. Let's make it 30 instead of 15. Now the movement is still too much, so I'm going to control the amplitude by adding another multiply node just after the vector 3. Now at this point, as you can see, it's starting to get a bit messy. My graphs always are messy. You can probably make them a bit better by using subgraphs, but you know, for this tutorial this will be okay. So here's a movement amplitude variable that you can control from the inspector. And yeah, something a bit more subtle like this I think is better. Let's make them go a bit further away. Okay. Now the issue is that when we loop from the normal position to the magical floating position, all the books move at once. So now we're going to create a new function that will actually fix that. So let's create a new random number and then a new float, which is going to be the floating books amount, right? And it's going to be a value between 0 and 1, which will be basically the percentage of books that are off the shelves. So we are going to subtract this floating books amount from the number 1. Let's make it a range so that we only have values between the 0 and 1, and then we'll subtract that from our random number. Then we'll just saturate that. And fit it into our two loop nodes, one for the position, one for the rotation. And now, as you can see, as we move this value, more and more books are going into their floating position. The last one is going to be to have the books actually go back into the shelves when the player is getting close to them. And that's actually fairly easy to do. So here I'll just create an empty that will act as our player. Let's call it player and bring it here. Now we're going to have to get the position of the empty to our graph, which I'll show you in a minute. First we have to subtract something from our looping factor and then saturate it again and then feed it back into the loop nodes. Now let's create a vector 3, which will be our player position. But for now I'll just leave it as this vector 3. So we're going to have to change the space because we're going to feed into the graph the world space, and the graph uses the local space. So we have to change from world to local. And then we're going to have to calculate the distance between each particle and the player. So to do that we use a distance node, not this one. A distance node, yeah, exactly. Just plug the two positions in there, and then with a few easy math techniques we should be able to get a factor of how close to the player each particle is. So let's just divide this distance by a factor that is going to be a property, and then feed it into our subtract. That won't be enough, of course. We have to saturate that, and we have to invert it by using a 1 minus, which is not technically an inversion, I guess, in math terms, but okay, now we're back to normal. Let's just name these properties. So this one is the distance from the player, from which books start going back into the shelf, and this one is just the player position. Now, to actually feed the position of the player to the graph, we're going to have to use a property binder. Pick position, and then just choose player position, and just drag the empty into the right slot. And then, yeah, my empty is completely off. Yeah, so you can see how that works already. Let's just add a sphere so that the empty is a bit more visible. And let's just, yeah. Okay, yeah, no, not the sphere. And here you go. Now the books are going back as the player gets closer to them. And you also have this very easy to control, general slider to decide how many books are off the shelves or in the shelves. Now that's really all there is to it. I hope that wasn't too boring or too slow, because I'm really not used to making tutorials, and I'm not planning on making like a lot of them, but this was a very popular request, so I thought I'd give it a try. So yeah, just feel free to comment if you have anything that I could have done better. I would love to hear about it. Just to be clear, this is a sort of simplified graph of what I actually made. So for example, I mentioned that there is no rotation movement, but I think you have all the techniques and information that you can need in order to make this a bit more in-depth and a bit better looking. Feel free to check out my Twitter, on which I'm releasing regular updates on my game, which is called Mona.